Hi friends, we are now constantly hearing in the news today about solar storms that is going to hit our earth very soon. They generally say these are being generated because of some solar flares that is happening on the surface of sun. Recently a solar flare of M intensity has occurred in month of May, and in month of June we have heard there is some solar flare of intensity X. So these are being constantly heard in our news and newspapers. So are these solar flares are dangerous to our earth? Does they damage our system? So let's find out what are these solar storms and how they are happening and how they impact our earth. Let us see in this coming video. So solar storm, what is solar storm? A solar storm is a magnetic geomagnetic storm which is temporarily a disturbance in the Earth's magnetic field caused by a solar wind. So now we are going to see why this is happening and how this will impact our Earth. So first, before we understanding about our solar storm, we will try to understand some facts about our sun. As you see, it's a glowing ball of fire, so which is our source of existence, including plants, animals, as well as our human species. So any activity happening on the sun is direct or indirectly have a consequences of our life systems. The sun is a gaseous ball made in a plasma state. A plasma state is a fourth state of existence where it is a superheated gas. Our sun is having a radius of about 7 lakh kilometers and distance about 150 miles, million kilometers from our earth. If we compare the size of our sun and of our earth, our radius of our earth is around 6,000 kilometers, and we compare to the sun, which is around 6,95,000 kilometers, which is around 100 times bigger than our earth. So a light generated from surface of sun to reach our place really takes 8 minutes, because the distance between our earth and sun is around 150 million kilometers. The sun rotates on its axis as earth rotates, but as it is a gaseous sphere, on the equator side it takes 25 days to complete, and it is 36 days on the pole side. So this is called the differential rotation of sun, because as it is not a solid sphere, the gaseous masses rotates at different velocities because of the Coriolis force component. Our sun is made of hydrogen and helium. By mass, if we compare, it is around 70%, and by helium it is 27%. So it is located in our Milky Way galaxy, called as Orion's spiral arm. It is taking around 230 million years to rotate to complete one cycle in our galaxy. Our sun is rotating at a speed of 7 lakhs kilometers per hour, so it is very speed. Before we go into next session, we learn about what is the sun made of. What are the internal parts of sun? So actually sun is made of 3 internal layers. They are called as core, radiative zone and convective zones. The core zone is at the deepest side where the total nuclear fission takes place. Its temperature is around 15 million degrees Celsius, which helps the hydrogen atoms to fuse to form helium, which is the basis for the whole energy of the sun. This energy is radiated outside towards the radiative zone. From here, the energy generated in the core takes nearly many years to come out into the convective zone because of the zigzag path followed by the energy inside this radiative zone. It is estimated that sometimes it may take around 7 lakh years a photon to travel from core to the convective zone. The temperature in radiative zone is around 7 million degrees Celsius. So from here, once it exits this radiative zone, next it enters the convective zone. Convective zone is a zone where hot material rises from the radiative zone and travels up until it cools down and again flumps back into the radiative zone. It is something like water boiling. When you see, it rises up and comes down. That's why it is called as a convective zone. The temperature in this convective zone is around 2 million degrees Celsius. So this is a very hot place inside the sun. Outside these three layers, there are outer layers called photosphere, which is the external surface of the sun, which is really visible to our visible side of the sun. From here, where sunlight is emitting. This surface photosphere is around 5,500 degrees to 6,000 degrees Celsius in temperature. This is normally visible as a red color or orange color, and this gives rise to a greenish structure for this photosphere. Beyond this photosphere, there lies sun's atmosphere, and this is divided in two zones, that is chromosphere and corona. The chromosphere is having around 200 kilometers thick and glows in red color. The temperature here reaches around 10,000 degrees Celsius because of the other factors coming into picture. The next comes is the corona layer, where it is a beautiful butte white in color. Generally it is not visible to our naked eye or any other instruments, because generally this is dominated by the surface of the sun, mostly the photosphere. This is visible only during the solar eclipse because the moon blocks the entire sun and just giving us only the glimpse of the atmosphere of sun. So this brightly illuminates the surface surrounding the sun's atmosphere. The temperature in the surrounding of the sun atmosphere can reach sometimes up to 2 million degrees Celsius. So the next we are learning is sunspots, how the sunspots form and how they are related to the solar storms. The sunspots we are seeing in the background image are the darkest spots randomly located on the sun's surface. They are generally termed as sunspots. Actually, these are the highly concentrated magnetic fields. These are generally cooler in temperature when compared to its surrounding areas, because the magnetic field lines, when break through these points, generally block the internal heat to radiate into the surface. So the temperature here in this spot will be generally less compared to its surroundings. So locally this is a cold spot compared to the neighboring places. So these dark spots are called as sunspots. Actually, the sunspots are concentrations of high magnetic fields. Generally, the sunspots occur in pairs, like a pair of pairs in the magnet, like North Pole and South Pole. So generally a magnetic line breaks the surface of the sun and enters again into the surface of the sun at the other point. So these 2 points are called a pair of the sunspot, forming a pair. So we can see in the adjacent figure that how these lines of magnetic loops are been seen in the sunspots. So this is how these sunspots are having their specific significance on the surface of the sun. These sunspots follow a specific cycle called solar cycle. That means the sunspots number increases from a minimum number to a maximum number and return back again to the minimum number. This increasing and decreasing of these sunspots takes around 11 years. So when sunspots are minimum on sun surface, it indicates the activity on the sun as solar minimum. And when the sunspot surface increases up to the maximum number, it indicates some maximum number of solar activities happening on the sun surface, and it indicates the solar flares or solar prominences occur during this period. So this is described as solar maximum. So from solar minimum to solar maximum and again to solar minimum, it takes 11 years. This is called as a solar cycle. During this solar cycle, we can see that the polarity of sun changes, magnetic field. Whatever you are seeing is solar minimum, where sunspots are negligible. And during solar maximum, you can see more number of sunspots available on the sun surfaces. The sun, during this reversal of magnetic fields and again back to the magnetic initial polarity, it takes 22 years for the sun. This is called sun magnetic cycle. Let's find out how these sunspots are forming. The solar magnetism generated is due to the differential rotation of sun and as well as the convection of the sun interior surfaces. Due to these two activities, one is rotation and other is a convection, these two are acting in a perpendicular direction to each other. So this makes the magnetic lines to form into a loop-like system. This differential rotation converts these straight lines into curved lines and again twisting due to its Coronavirus forces. As you see in the diagram, how we can visualize how these lines of force has been transmitted and finally how it's forming into a loop. So these loops, whatever is formed inside, are the magnetic coils, and during this sun cycle, whenever it is maximum, due to convective zone where this hot magma or hot material is falling and rising, these loops are also will be coming out of the sun surface. As you see, the magnetic lines of force has been ejecting out of the sun surface and again entering into sun surface. The way the point it is ejecting and where it is entering, they are both are sunspots, and they are places of tremendous magnetic fields. And this place where it is coming out is called as a kink. And as you see, these are the rubber tube which are shown for understanding purpose. So as you see in this diagram, the coiling of the magnetic lines and how sunspots are pairing and how the sun prominences are coming out of the surface of sun. These are the lines of force of magnetic field which are being forming into loops because of the rotation, differential rotation, and as well as the convective zone inside the sun. You can see the size of the earth and size of the sunspot. Generally they are very big and compared to the size of the sun. So the sunspots are the major places of sun activity. These are the only places where we find solar flares or solar prominences or coronal mass ejection happening in. Whenever there is a solar minimum, the activity of sun is almost nil. But whenever this solar maximum is there, we find a solar flare happening. The solar flare can term as when the magnetic loops which are coming out of the sun surface are disturbed or broken out. they create a sudden violent explosion in the form of gamma rays, X-rays, and float into the space. You can see how the sun is ejecting some of the material outside surface. It has some flares has been classified according to their strength as B, C, M and X, where B is having the minimum intensity, which is generally not noticeable, and X is the maximum side. So here you can see the red hot glowing sun with flares, as well as some mass ejection has been taking place. So we can see here how sun is with real sun with solar minimum and solar maximum, how activity is going on. These are all flares on the sun surface with different intensities. These are all the mass of sun being coming out from the loops of the magnetic loops. Whenever a magnetic loop has been broken, it forms a flare and giving rise to some high intensity X-rays, gamma rays into the sky of the solar system. So these are the levels of intensity of the solar flares B, C, M, X, and each having its own classification from B, C, M 1 to 9 in each classification, and X itself is having 1 to 9, and each is 110 times more intense than the other. These are the intensities on the surface of Earth due to various solar flares classified as M and X, and how they are affecting on the surface of Sun geomagnetic field. These are the flares. The Sun is glowing in green color. This is taken in a different wavelength, especially in ultraviolet length. So we can see a strong solar flare ejecting out, and you can see the effect on the Earth surface as auroras, or the northern lights and southern light. This is the charged particles interacting with the Earth surface or Earth atmosphere. The coronal mass injections are a next form of the solar flares, where some of the mass from the sun surface is ejected due to a very high disturbances happening on the sun surface, and this is a charged mass traveling with a very high speeds towards the planets of the solar system. They can influence a lot on the geomagnetic fields of the Earth. They are almost twice as big as the Earth itself. So you can see both the sun flares as well as coronal mass ejections happening on the sun surface. These images are taken in a red wavelength. The coronal mass ejection, when they are emitted from the sun surface, they travel with very high speeds as wind, these charged particles called as solar wind. And when they impact the surface of Earth, the surface of Earth have magnetosphere around it, which protects or which interacts with these charged particles, forming high intensity lights in the sky, which has been visible as auroras, or sometimes called as northern lights or southern lights. These are the effects of the impact of the solar flares on the Earth. These are the recent activities which we have recently heard, like the X solar flare, which has been in news today, which has happened this month, has been seen from the green side, which is an ultraviolet region spectrum, and it created a coronal hole where this indicates some kind of mass has been ejected out of its surface, and it has been traveling into the space as solar wind, and at any time it can hit the earth within 2 or 3 days. What are the possibilities of these effects on the earth? These can lead to like a power grid failures, a complete blackout of the power system, especially in the northern regions, GPS navigation system interruption, satellites can be damaged, and mobile communication will not be proper, no internet facilities, no radio communication will be totally wiped out for some time. This will be seen in the form of northern lights, or called as auroras or aurora borealis in the northern hemisphere. So these storms on the earth is indicated by some number called K index or KP scale. Generally it is termed in the form of integer 0 to 9. When this K index indicates 1, it is a calm based solar storm or geomagnetic storm, and 5 indicates a severe geomagnetic storm. Generally G scale has been used by US, so both are in use. The present solar flare, which is intensity of X 1.3 and associated solar storm categorized as K4 or G0. So you can see here the different index numbers and their associated activity. Generally G0 K4 gives a quiet atmosphere in the other regions of communication, but it's having a aurora activity that's still actively seen in the northern hemisphere. This is the aurora borealis over Canada, which is due to the X type of solar flare burst. So this continues for hours or sometimes days. Is it the shower of some charged particles when interacting with the atmosphere with the nitrogen and oxygen? This kind of blue-green lights has been visible over the most of the northern hemisphere around Arctic Circle, Canada, parts of US, Europe, as well as Russia. This you can see how it is impacting the surface of Earth due to the solar wind. The charged particles are constantly bombarding on the surface of Earth, and where our magnetic sphere is helping us or protecting us from this intense solar wind. There is a loop where the solar particles can enter into our Earth atmosphere and interact with the atmosphere of Earth from the North Pole and South Pole. These are whatever we are seeing are the lights of that. Thank you, dear viewers. Keep watching for these interesting topics, and please do subscribe. So do not keep waiting for you. Thank you for watching.